All right, next we're going to take a look at one other similarity theorem, and then we're just going to include one at the end here. So we have a side-side-side similarity theorem and a side-angle-side similarity theorem. So let's take a look at how the side-side-side similarity theorem works first. So we can see we have two triangles, and they told us some information right here. If you notice, they're not telling us anything about the angles. They're telling us some things about the sides. So when you're working with just sides, you're going to want to examine the scale factors. Remember, those scale factors are the ratios of corresponding sides. So what they told us was that side LM over side PQ, and I'm going to go ahead and highlight those with my red pen here. Here's LM. We're putting that over PQ, so those are corresponding sides. That is equal to, our next side is MN over QR. So we're told that MN over QR, so those are going to be corresponding sides. And because we're saying that they're equal right now, we know that the ratio of these corresponding sides is equal to the ratio of those corresponding sides, so those two would have the same scale factor. But they also told us that we have a third side, LN, that these are also equal to LN over PR. So LN corresponds with PR. And so what we are determining is that all of our scale factors are the same. So if scale factors of each corresponding side are the same, that means that the sides are proportional. So does that mean that we have similar triangles? So can we come up with a similarity transformation that would map one triangle onto the other triangle? We already know we've got proportional sides. So one thing, you can do a quick check on the orientation of your triangle. So if we're looking at triangle PQR, I'm going to go P to Q to R. I can see the orientation goes around that direction. And then I want to compare that to triangle LMN. Again, I'm just going back to the example. We want to know if this triangle maps onto this one. So if I start at L, I'm going to go to M and then N. Do you see how we are going different directions around the triangles? When that happens, that means that we have a reflection. So we can dilate because we have the same scale factors, those ratios of our sides. We're showing that the sides are proportional. So we can dilate triangle PQR and reflect to map onto triangle LMN. All right, so therefore, triangle PQR is similar to triangle LMN by the side-side-side similarity. All right, so let's just fill in some theorems here. If the corresponding sides of the two triangles are proportional, then the triangles are similar. And you can see right here, we're showing that the ratio of these corresponding sides, the ratio of these corresponding sides, the ratio of these corresponding sides are all equal to each other. When that's true, you have similar triangles. And let's just include, they are similar by the side, side, side similarity. Okay, so we didn't do an example with this, but we're just going to throw this theorem in there because I think we're catching on. If an angle, this one is side angle side, so if an angle of one triangle is congruent to an angle of a second triangle, so we only have one congruent angle, so we can't use angle-angle similarity. And the sides that include the two angles are proportional. So here's our congruent angles. If AB and DE, if that proportion, that ratio is equal to BC and EF, the two sides that have that angle included, then you have similar triangles. So then the triangles are similar. So we just looked at that picture over there. So then our triangle ABC is similar to triangle DEF by the side angle side similarity.